Hello, friends. Now we're going to talk about the graphs of transformed sine and cosine functions. So in the videos before this, we talked about our parent graphs. I'm actually going to scroll up here and give myself a little space. We talked about just y equals sine of x, as well as y equals cosine x. And then we also talked about tangent, as well as the three reciprocal functions, secant, cosecant, and cotangent. Um, we said that these two functions had a period of 2 pi. They had an amplitude of 1. Their domain is all real numbers, and their range is from -1 to +1. They're both continuous functions. We don't have any asymptotes to worry about. So now we're going to think about applying transformations. And if you took algebra with us at CFCC, you probably remember learning about some formulas that look kind of like this. We'll say A times some quantity Cx minus H, maybe squared, plus K. So you've got that H and K, which let us know about our horizontal shift and vertical shift, as well as A and C, which give us information about stretching and shrinking, as well as a reflection over either the X or Y axis. If you had this class with me, I've got some mnemonic devices that I like to use. So I'm going to talk about those real quick, and I'm going to say, well, we're going to apply that in the same way. Y equals, we'll say A times the sine of some quantity C x minus H plus K. So you should notice a similarity between what I've written here and these two transformed forms that we have. They all behave the same way. You may have just learned them with different variables before. For me, I say, when we're talking about the transformations that are attached to the x, those are inside the grouping mechanism. So that means it's a change horizontally or to the x. And then on the outside, this A and K, or here we have an A and a D, those are vertical. And adding or subtracting means a shift, multiplying or dividing means a shrink, stretch, or flip. And the last thing we like to talk about is whether or not it's inside or outside. So C and K are inside the grouping mechanism in the argument of sign. They're inside the parentheses. Whereas A and K, they're outside, they're free. So I think about like being inside, like in jail, because these guys were bad, because they always are going to behave the opposite of what we are going to expect. Whereas A and K, they are not trapped in the bars with the bad X. They are free to behave as we expect them to. They follow the rules. So A and K are free because they follow the rules. C and H are naughty. They're in jail with X, trapped in the bars. They always do the opposite of what we think they're going to do. All right, so you'll see as we work through some of these problems, you might notice I will have written added and on the outside. I'm just trying to trigger you to think about things the way you may have learned them in your algebra class before this. And if you had me, this should be very similar. So we're going to talk about each of these pieces separately. First, we're going to talk about this D. So D, you'll notice here, D is added. Added lets me think, okay, well, this is a shift and it's on the outside, which lets me know it's a vertical shift. So remember, when things are on the outside, they behave the way we expect. So if we have a D value that's greater than 0, that lets me know I'm going to shift up D units. And I just use those absolute value bars because we only shift, in a positive direction, or we measure things in a positive quantity. And if that D value is less than 0 is saying negative, then we would shift, you guessed it, down whatever that D value is, units. All right? So added on the outside, that's a vertical shift. So let's look at two examples. Here I have our standard sine graph. Starts at 0, ends at 2 pi, and you can see I have my 5 key points. You guys should all recognize those 5 key points, and when you're working on your lab, you're going to want to make sure that you can mark each of those 5 key points as they are transformed. So if we look at example A, y equals sine of x plus 2, that means we're going to shift up 2 units. So in words, we would say this means we're going to shift up 2 units. If we want to think about what that's going to do to our ordered pair, that's going to take my y and increase it by 2. So all of these key points, the y value, they're going to move up 2 units. So we have the exact same sine curve, it's just shifted up 2 units. And you want to make sure you're listing those points. So I'm not going to do this for both examples, but I'll do it on this first example. Remember, we know our key points 0, 0. We have pi over 2, 1. We have pi, 0. 3 pi over 2, negative 1, and 2 pi, 0. So those were my given 5 key points. And what happens to them is all of these y values, I'm going to add 2 to them. So if I were to list my new 5 key points, I would have 0, 2, pi over 2, 1 plus 2 gives me 3, pi 2, 3 pi over 2 plus, negative 1 plus 2. That's going to give me 3 pi over 2 positive 1, and then I have 2 pi 2. So I have 5 new key points. All right, so thinking about this, I'm going to erase those key points there. So thinking about this, if we have sine of x minus 1/2, what does that do to our graph? In that situation, we are going to shift down 1/2 unit. Notice I wrote the positive value because we're saying we're going down 1/2 unit. So that means I'm going to take all of my x, y ordered pairs and subtract from them 1/2. So moving each of these points down 1/2 a unit, my new sine curve for part B looks like this. And my key points would be 0, negative 1/2, pi over 2, positive 1/2,